these types of problems, find the sum of the measures of the interior angles of a polygon. Very basic stuff, but obviously, I mean, one of the big keys to second semester is knowing formulas and being able to apply them. Okay? That's going to be one of our big keys all semester long. You got to know your formulas. You got to be able to apply them in the right situations and know which formula to apply when. So that's going to be our biggest challenge all semester long. So the formula for sum of the measures. Now, key word here, find the sum, not just each. Because there's another problem later on where it says find the measure of each interior and each exterior angle. That's different. So the sum, what's the formula for the sum? Anybody tell me the formula for the sum? There we go. Thank you very much. Number of sides minus 2 times 180. So a pentagon, well, in order to do that, I'm going to have to know how many sides are in a pentagon. How many are in a pentagon? 5. Pent, 5. Okay, so the number of sides is 5 minus 2 times 180. 5 minus 2 is 3 times 180, which is 540. A 21 gon. Obviously, it has how many sides? It's 19 times 180, which is how much? 3 times 4. Wait, how do you know it's 19? Because 21 minus 2 is 19. Oh. And how about an 18 gon? 16 times 180. 180. Which is what? 2880. Okay. So again, hopefully you did those and got those right. And you did the practice, but you will see problems exactly like that, just different numbers. I mean, it's not going to say pentagon, 21 gon, 18 gon. Maybe it'll say octagon, 14 gon, 23 gon, or something like that, you know. I mean, same type of question you'll see on the quiz tomorrow. This looks familiar. Should be the same one that's on your sheet. Find the value of x. Now, in order to find the value of x, first I'm going to have to know the sum of all those angles, aren't I? How many angles do we have? 1, 2, 3, 4, 5 angles. So that is a pentagon, isn't it? What's the sum of the angles of a pentagon? Fortunately for me, I just figured that out. What was the sum of the angles of a pentagon? 540. So 105 plus 2x plus 98 plus 112 plus 3x has to be 540. And I want you to notice something about how I set this up when I'm doing it on the review here, because this helps you set it up on the test and make fewer mistakes. I didn't try to add all the angles up first in my head and get a sum. I just wrote out the whole thing. So I know exactly what I'm doing. And then I can start combining like terms. Okay? 98 and 112, that's going to go together. That's 120, 210, 315. Plus 2x and 3x is 5x equals 540. And I can minus the 315. And I get 5x equals 225. So divide by 5. And so x is 75. Is that right? 225 divided by 5? No, 225 divided by 3 is 75. 225 divided by 5 is 45? 45. Sorry. So x is 45, and it says find the value of x, so we can stop. Now, if it said find the measures of the angles, what would we have to do? I'd have to substitute this 45 back in and say this is 2 times 45, that's 90. 3 times 45 is 135. So depending on what the question asks, give the appropriate answer. Always make sure you're answering the question that's asked. Find the value of x. This time we're dealing with exterior angles. Exterior angles are easy. Why? Why are exterior angles so easy? They always add up to 360. It doesn't matter how many sides you are. If you have 3 sides or 117 sides, the sum of the exteriors is always 360, right? So again, I set up a really simple equation. 3x plus 80 plus 2x plus 110 has to equal 360. So 5x plus 190 equals 360. Do the algebra. 5x equals 170. So x is 34. I think. Yeah. I know some of you are looking at me like, how do you do that? How do you get 34 so fast without a calculator? Well, honestly, I know 10 fives is 50, right? So 150 is 30 fives. Fives are easy to work with. Okay? I have 150, that's 30. How much is left? 20. How many times 5 go into 20? 4. Because fives are easy. 34. You think of it 17 times 2? Oh, yeah, okay. And double it, then 10. That works too. Yep. Find the measures of each. Now, I made this bold capital letters here, but I don't think it says it on the test, but it's very important. Each interior and exterior angle for the indicated polygon. So, here's where we can use a little bit of strategy. I do not need to find the sum. You can. You could find the sum and then divide by the number of sides, and you'll find the measure of each. Not number of sides minus 2, number of sides. But what's much easier, if this, say, were one intersection of a polygon. It has many, many sides. I don't know how many. But this is just one intersection of it. One vertex. Okay? This is an interior angle. I'm going to find the exterior angle. I simply extend my side a little bit, right? And this is the exterior. What do I notice about an interior and exterior when I put them together? What do they form? What is it? Straight line. Okay, linear pair. Supplementary angles, which means they have to add up to what? 180. So an interior plus an exterior always has to equal 180. So if I ask you for each interior and each exterior, then 2 numbers I get better add up to 180, right? Now, what's going to be easier to find? The measure of each interior or the measure of each exterior? The exterior is way easier to find because the sum is always 360. So to find each angle, each exterior is simply 360 divided by the number of sides. So the exterior for a septagon is 360 over 7. Septagon is 7. Think sept. September, October, November, December, 7, 8, 9, 10. Now, yeah, they are not months 9, 10, 11, and 12 in our calendar because they were originally months 7, 8, 9, and 10, but Julius Caesar thought he was pretty awesome, so he created a month and named it after himself in the middle of summer, hence the month July. And then Augustus Caesar thought he was just as cool as Julius, so guess what? We got August. So July and August are named after Julius Caesar and Augustus Caesar, and that's why the months that were 7, 8, 9, and 10, Sept, Oct, November, December, are now 9, 10, 11, and 12. That's why they're out of order. See, a little history lesson. Little history lesson in there. But know your Greek and Latin, and everything is much easier. So the exterior would be 360 divided by 7, which does not give us a nice number. Oh, dear. That's 51.4 degrees. So each interior has to be 180 minus that, or 128.6. degrees. Okay. How about for a 16-gon? What's the exterior going to be? 360 divided by? I didn't give you what? What do I'm going to divide by 360 by? 16. Okay. Oh, no, it's a half? Really? I consider anything with a half a very nice number. Okay? It's exactly 22.5 degrees. If I get an exact answer like that, I consider that nice. So my interior is going to be 180 minus that 157.5 degrees. Okay. So interior, exterior, again, fairly straightforward. Find the exterior, each exterior first, because that's the easiest thing to do. The book will take you, if you look at the book, you look at other things like that, they're going to take you through the whole process of finding the sum of the interiors and dividing them by the number of sides and get this big number, and you got to divide by a different number, and it's so easy to mess up because to find the sum you have to do n minus 2, but then you have to divide by n, not n minus 2, and people get all messed up with that. Forget that. Do the exterior. Much faster, much safer. One quick little division, and you have a calculator. All right, this is a problem that's going to mess a lot of people up right here. Because it did in the homework. It did every time we looked at this. I mean, you had one in the journal, you had one out of the book that was like this, and pretty much people struggled with this one a lot. But don't forget we can simplify our pictures. Okay? I can always just draw a copy of my big parallelogram here, ABCD, without the diagonals and just marking what I know about that. This is 11, this is 17, so this has to be 11 and this has to be 17. What else do I know about my big exterior parallelogram? This angle is 70 plus 45 put together, right? So that's what, 115? So what's this angle got to be? 115. What's this angle going to have to be? Mr. Churchwell, can you help us with that?
The information not provided for me.
Oh, okay.
24.
It's an excellent try. I like that. Oh, I will.
I'll be down my side of the moment.
Fiver?
Yeah.
Okay. I think that's all I got. My well-qualified, my beautiful... Is this not the best-looking geometry class that you've ever seen, excluding the teacher? Oh, well, yeah.
What do you got? What is this?
Geometry.
Oh. That's that.
That'll be in the podcast. All right. So what's this angle going to be? 65, because consecutive angles have to add up to 180, right? And 65. Now, just based on that alone, how many questions can I answer? CD, aha. Okay, DE. I can't do DE yet. That's okay. Angle ECD, nope. EBC, no. BEA, no. AED, not quite yet. Okay? So, but we got this one. Okay? One thing at a time. DE. Okay, let's take a look at my diagonals. DE. D to E. Oh, the diagonals bisect each other. So if this is 8, this has to be 8. And if this is 12, this has to be 12. ECD. Let's find that one. ECD. That angle. Couple ways I could know it. If I had like a Z, I could do that. But what do I notice I have here? I have what kind of shape? What is this shape?
Square.
Yeah, good. Triangle. What is the sum of the angles of a triangle? Have to be 180. I know 2 of the 3 angles, don't I? So if I have a 65 and a 70, that's 135. What does that leave me for the other angle? 180 minus 135, which is 45. Okay, so this angle now I know is 45. Now I know the whole angle is 65, so what does this angle have to be here? 20. Okay? And now I'm able to start figuring a lot of things out, because if this angle is, this angle is 65. What does this angle have to be? 115. And so if I got 115 and 20, then this is going to have to be 45 up here. See how it's like a puzzle? We just start putting the pieces together. And we just keep working it. AED, AED. Oh, that's vertical to this one, so it has to be 115. BEA, BEA. Oh, it's vertical to this one, so it has to be 65. And EBC, EB. Oh, we got that already. 45. What do? I start working things out and simplifying pictures. And instead of trying to look at the whole thing at once, when I just needed this triangle, I just looked at that triangle. It's not a bad idea to carry some colored pencils with you for the test, or a highlighter or something, so you can highlight out just the part you need and help separate that out. Take that complex picture and make it simpler. Break it into its component parts sometimes to help yourself out. Sometimes you need the complexity, but a lot of times a simpler picture will help you find it out. Okay? State which theorem you could use to prove the following are parallelograms. Now, you do not need to know theorem numbers. In fact, I don't care about theorem numbers. So don't spend any time memorizing this is theorem 7.4, this is theorem 7.5. Numbers mean nothing to me. All you have to do is tell me which theorem is being illustrated in words. So what do I have here? This is
Parallelogram.
Y. We know it's a parallelogram. Obviously parallelogram. How do I know it's a parallelogram?
Parallel line.
Well, what choice do I have to prove something's a parallelogram? I have 5 ways of proving something's a parallelogram. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Diagonals bisect each other. Or one pair of opposite sides is parallel and congruent. It's got to be one of those 5 statements.
Last one, the one pair.
So that's what you have to write then. You have to write that little phrase. One pair of sides is both parallel and congruent. Okay? So you actually write out what the reason is.
Cool.
Okay? Saves you from having memorized theorem numbers, and like I say, theorem numbers are arbitrary anyway. The author of the book decides what the theorem numbers are. There's no standard for that. So every book's going to have different theorem numbers for the same theorem. But they all have the same theorem, that one pair of sides parallel and congruent makes it parallelogram. How about this one? Which reason is here? Both pairs of opposite angles congruent. And notice I often use a congruent symbol instead of writing out the word congruent, because I'm lazy. But you could be lazy like that too. Quite honestly, if you just wrote both pairs of opposite angles there, I'd probably be happy with you and give you the points. You know what you're talking about. You can't just write both pairs of opposite sides, though, because there's two reasons. One is parallel, one's congruent. So you got to be a little more careful with that. Okay. Prove that the quadrilateral with these vertices is a parallelogram. This is what we did at the end of the day yesterday. Now, here's where we talked about in the podcast, the communication piece comes into play. A lot of times what you're going to want to do, and I believe on the test I do have a graph already on there for you. Graphing it is helpful. Graphing it is not the proof. But graphing it is helpful. So A is at 0, 0. Whoa. What's going on there? Hello. Oh. Well, that's interesting. Random recalibration necessary. Let's try this. This is always fun on the podcast when I'm recalibrating the smartboard. So if someone is watching this somewhere, ever, sorry about that. All right. There we go. Seems better now. Okay, so A was at 0, 0. B is at -2, -2. C is at 2, -4. And D is at 4, -2. Okay. Why do I draw it? Because I want to have the picture so I know what is a side and what is a diagonal, depending on what method I want to use. Now, I have to pick a method to prove that it's a parallelogram. Basically, you can choose anything other than opposite angles congruent. I can't prove angles congruent in the coordinate plane very well unless they're all right angles. I can use slopes to show perpendicular lines. I have to use sides congruent or midpoints or things like that. Now, whatever you do, label it clearly what it is you're doing and then state your conclusion based on what you've done. I'm going to do this using slopes. And what am I proving using slopes? I'm proving sides are parallel. Slopes prove things parallel and perpendicular. So I'm going to choose to do this using slopes. You could choose using distance formula. You could choose using midpoints of diagonals. It really doesn't matter. So what I'm going to do is I'm going to say what I'm finding. I'm going to start with the slope of AB equals. So I write what it is I'm finding, and I show my work. Slope of AB would be 0 minus -2 over 0 minus -2, which is 2 over 2, which reduces to 1. That's going to have to be a parallel to CD. So slope of CD equals -4 minus -2 over 2 minus 4. So that's -2 over -2, which is 1. Aha! They have the same slope, so I make my conclusion. AB is parallel to CD. And kind of circle that. Aha! I've made a conclusion based on what I've done. Am I done? No, that's one pair of sides parallel. Now I go BC. Now, at this point, I could stop. I could say, wait a minute, maybe I'll do distance formula on those two sides too. They seem like they're pretty easy. I could do that, show one pair of sides parallel and congruent, or I could go on and show all four sides parallel. It's really your choice. But what I don't want to see is people finding the slope and then saying AB is congruent to CD. Slope does not prove congruence. It proves parallel. So slope of BC equals, show my formula, -2 minus -4 over -2 minus 2. -2 plus 4 is 2. That's over -4 is -1/2. Slope of DA equals 0 minus -2 over 0 minus 4, which is 2 over -4, which is -1/2. Aha! They're the same, so DA is parallel to BC. There's my conclusion. And then how do I know it's a parallelogram? Because both pairs of opposite sides are parallel. My A just doesn't want to come out there. Let me write parallel again. So I show my work, I make my I clearly label my work, show all the steps of it, and then once I've got everything done, I state a reason why it's a parallelogram and one of my theorems. Whatever, you should know what this statement's going to be before you even start, because that's why you do the measurements you're doing. If you're finding the midpoints of segments or diagonals, write midpoint of AC equals midpoint of BD equals, and show your work. And then say something like same midpoint, diagonals bisect each other. But if all I get is a picture, a problem like this is usually worth double points, just so you know, because there's a lot into it. There's a lot of work that goes into it. But if all I get is just a picture of the shape, you get almost no points for that, because the picture is not proof. We don't have to do the 2-column statement and reason proof anymore, but we do a lot of these this semester, and it's all about how you communicate what you're finding and what your conclusion is. You got to know the right formulas. That's why we spent so much time on that last semester. Now that you know the formulas, now you have to be able to apply them appropriately and communicate about what you're doing. Any other things you want me to go over? Okay, so we're going to save this, and then I'm going to come around and I'm going to check your check sheets.